So in this lesson, we're going to look at actual problems that have to do with sampling distributions, full types of problems like ones you would see on the Regents. So the first one says, Anne has a coin. She does not know if it is a fair coin. So a fair coin would mean that it's heads 50% of the time and tails 50% of the time. She flipped the coin 100 times and obtained 73 heads and 27 tails. So what we would say here is that from her sample, the one she's wondering about, that her proportion from this sample is 73 out of 100 heads, or 0.73. Now, we would expect 50%, but is 73% or 0.73, is that an unusual value for 100 coin flips? That's really what we're asking. So she ran a computer simulation of 200 samples of 100 fair coin flips. So they're hard to see, but there's 200 dots. Each of them represents 100 fair coin flips, which a computer can do very quickly. The output of the proportion of heads is shown below. Now, we know that we could cut dots off both sides, but they gave me the mean and standard deviation. So when we have that option, we use that to find a confidence interval. So we know the confidence interval is the mean. And we're finding a confidence interval because, remember, these coin flips came from fair coin flips, or this simulation came from fair coin flips. So this is what happens with fair coins. We're going to add or subtract 2 standard deviations, so 2 times 0.050, and that's going to give me a confidence interval from 0.397 to 0.597. Now, we can also see that her sample of 0.73 clearly falls outside the confidence interval. It's even off the graph. So what that means is when we ran the simulation for what a fair coin does, we didn't even see one time that it was 0.73. It's definitely not in the confidence interval. So looking at our choices, it says 73 of the computer's next 100 coin flips will be heads. Well, that one's kind of silly, right? We don't know what the computer is going to do if it's being random. 50 of the next 100 coin flips will be heads. Also, don't know that. So then we get down to the 2 we have to decide between. Do we think that her coin is probably fair, probably not fair, or probably fair? So because her number falls outside of the confidence interval, we're pretty sure it's not a fair coin, right? Otherwise, we would have gotten a proportion between the 0.397 and the 0.597. So let's look at the next problem. This one has a little different take on things in terms of what it's asking. It says a study conducted in 2004 in New York City found that 212 out of 1,334 participants had hypertension. So that's like an issue with high blood pressure. Kim ran a simulation of 100 studies based on this data. So we have 100 dots here. The output of the simulation is shown in the diagram below. So here's our diagram. At a 95% confidence level, the proportion of New York City residents with hypertension and the margin of error, so how much are we going to go out to each side, is closest to which one of these? So looking at the graph, this proportion is like that average, we think it's around 0.16, but it goes to the sides. So we want to pick either choice 1 or choice 2. Now we don't have a mean and standard deviation, so we have to kind of eyeball it. So here's our mean. If I am going to cut off, right, we have 100 studies, simulation of 100 studies. So if I do 100 times the 0.025, I'm going to cut off 2.5 or about 3 dots from each side. So that's going to cut off some of these over here. So we're probably going from about here and a couple over here. So my margin of error here, it looks like this would be my confidence interval. I know this isn't great with the pen. So my margin of error from the mean or the mean proportion to the side is 0.02, from 0.16 to 0.18. So we want to choose choice 2. Looking at the next problem, it says a radio station claims to its advertisers that the mean number of minutes commuters listen to the station is 30. So they're claiming 30 minutes. Okay, so 30 is our thing that we're going to be comparing and testing. The station conducted a survey of 100 or 500 of their listeners who commute. The sample statistics are shown to the right. So they basically, the sample of the 500 had a mean of 29.11 and a standard deviation of 20.718. So on average, about 29, and people were like plus or minus 20 mostly from there. So a simulation was run 1,000 times based on the results of this survey. So they ran a simulation based on these results, and this is what appears to the right. So we have 1,000 dots, but we don't have to cut off dots because we do have the mean and the standard deviation of this sampling distribution. So we're not really using this other than the fact that they use this number here to do the simulation down here. Based on the simulation results, is the claim that commuters listen to the station on average 30 minutes plausible? Explain your response, including an interval containing the middle 95% of the data rounded to the nearest hundredth. So we know this means our confidence interval. So we're going to do mean, which from here is 29.101 plus or minus 2 times 0.934. So we've done that enough. If I type that in to the nearest hundredth, I'm going to get between 27.23 and 30.97. So that's our confidence interval, or 95% confidence interval. So we'll just label it, put a 95% on just so it's clear. Now our question is, based on this data, is it possible that the 30 minutes could be correct? So we can see that the 30 falls in the confidence interval. Also graphically, the 30s here, it looks like it would be in the confidence interval. So we can say, yes, 30 minutes is plausible. It falls in the confidence interval. Okay, so something like that, a simple sentence will cover that. Looking at the next page, these are actually the questions that show up on Delta Math, which is we're going to have our homework. So they're similar. The last three were from a Regents exam or from different Regents exams. So this one says a survey of 80 high school students was given to determine how many people were in favor of forming a new rugby team. The school will form the team if at least 30% of the students at the school want the team to be formed. Now, in their survey, they surveyed 80 people, so that's their sample. 20 said that they wanted the team to be formed. So that from that sample, so what I just circled in red is your observed proportion. That's what's happened. We want it to be 30. It ended up being, let me just get a different color out, 20 out of 80, which is 25%. Now it's a sample, so we know it's not going to be exactly what the whole school wants, right? Exactly the whole population of the school. So now they said to test the significance of the survey, a simulation was done assuming 30%. So this simulation is based on 30%. The sample size was 80. It was repeated 200 times. So we have 200 dots down here. We're going to create a 95% confidence interval based on the data from the simulation to the nearest hundredth and state whether the observed proportion, so the 0.25 or the 25%, which we should write as 0.25, is within the margin of error of the simulation results. So we have our data here. We don't need to cut off dots. We're going to do our mean plus or minus 2 standard deviations. And if we did that, that is going to give us to the nearest thousandth or nearest hundredth, it says to round to here. This one is going to be 0.20. And this one is going to be 0.40. So that's what it rounds to. So this is our confidence interval. We assumed the 30%. If the whole population of the school has 30% of them want the team to be formed, if we take samples of size 80, we're expecting them to fall between 0.20 and 0.40, or at least 95% of them will. So the observed proportion, here's our observed proportion of 0.25. And then this one is, here's our drop-down choices, is within the margin of error. So sometimes we say within the confidence interval, sometimes we say within the margin of error. They basically mean the same thing. Of the simulation's assumption that 30% of the school favored the team. So this question doesn't take it further, but what they're saying is, yeah, we got 25%, but that could still mean that the school has a population proportion of 30% because the 0.25 falls in that confidence interval. So on the next page, we have our other type of Delta math question. We'll just read through it. The senior class president of a large university claimed, so we see once again a claim. Remember last time, not really a claim, but we were hoping for the 30%. Here we have a claim that 65% of the senior class was interested in going on the senior trip. So that's what he claims. To test this claim, the senior class president conducted a survey of a random sample of 100 seniors, and 76 said they wanted to go on the senior trip. So what we observed, we'll circle that in red again. And this observation is just like what we observed with the last survey. It's like what we observed flipping that coin that ended up thinking it wasn't fair. Okay, so that's kind of a common piece of each of the problems. So that's 76 out of 100 is what we observed, which is 0.76. To better understand the significance of the survey results, a simulation was devised based on the claim that 65% of the seniors wanted to go on the trip. So this simulation is based on 65%, which is why we see 65% towards, or 0.65 towards the middle. Explain how the results of this simulation can be used to support or refute the senior class president's claim. So what we're going to do, this one's a little different. This is our first time we're looking at something called a one-tailed test. So usually we think about cutting 2.5% off each side to make a confidence interval. In this problem, the way it's worded, we're just going to look at the one side and see if it's in 5% on that side. So we're going to put the whole 5% that's, goes with the 95% on one side. So we'll see how it works. So let's just find the 0.76. Notice we don't have any mean or standard deviation statistics. So we are right here. Okay, so looking pretty on the outside. So here's our pull down menu options. We're just going to move that up. So since the simulation shows, and in this case we're on the side, so there's few cases, okay, and specifically we're going in this direction. So we're always going to go away from the middle. There are few cases with a sample proportion of, we're going to be comparing it to our observed sample proportion, so of 0.76. And since we're going in this direction, we're on this side of the graph, or greater, the claim that 65% of the senior class wants to go on the senior trip is likely not true, okay? If we were somewhere in the middle, like in, let's just say the confidence interval went from about like here to here-ish or something like that, that was our confidence interval, then we would say, yeah, like, it could be true, but we're outside of that. And specifically this time we're to the higher side, which is why we said greater, okay? Now, we don't really ever pick definitely true or not true when we are given these quite reasonable and likely not true choices, because we're never really sure of anything, honestly, in statistics. We're pretty sure, like 95% sure, but we don't ever say, like, we're sure this is true. Okay, it's really hard to do with statistics. So if let's say the observed proportion, instead of this being 0.76, let's say it was just 0.7, we would have been here, and we still are on the same side. So if we went greater and I counted up all these dots in here, that would be many cases, more than 5%, in this case, more than 5 of the 100 that are on that side. Okay, so hopefully you have time in class, you'll be working on these and the Delta math. There's examples and stuff so you can look at them too.